So here's my solution. First, I use randint to assign the true location of the car. And my initial guess, called guess 1, is also chosen at random. And you see these independent random choices with equal probability. And now there's two possibilities. Either truth is equivalent to guess, or it isn't. When truth is equivalent to guess, Monty will pick one of the two other doors. So let's just implement this. I will let Monty pick a random door using randint. And of course, he might have picked the correct door, which contains the car, which is also my guess. And when that's the case, I just rerun the random number generator until it finally finds a door that is not the true door, or equivalently not the guess. And that's his pick. So if you look carefully, this might run a number of times, but when it returns, he picked one of the remaining doors with 50% chance. In the else clause, the truth and my guess are not the same. So Monty now has to pick the remaining door with probability 1. How do we get Monty's choice? Now I'm going to do a little cute trick. I know that the sum of all doors, 1 plus 2 plus 3 equals 6. So if I subtract from 6 the truth and my guess, I get the third door. So this equation, 6 minus truth minus guess, will give us the number of the door that isn't truth and isn't guess 1. To flip my door, I can now do the same trick I did over here. I pick the one that wasn't my initial guess, which is a subtract guess 1 from 6, pick the one that isn't Monty. So that gives me guess 2. And if that guess is the same as the true door, I increment k by 1. And then I return the final number over here. So this gives me a single simulation. I want to do this n times. So I add a loop for I in range n, move everything to the right a little bit, and then the simulation is run n times, returning my desired ratio of the successes over the total number of experiments. So let's run it. When I run it 1,000 times, I get a number like 0.672. That's not exactly 2/3, but obviously there's some randomness involved in the simulation. If I increase n to 10,000, I get a number slightly closer to 0.66. Do it for 100,000, I get 0.66748. And that is awfully close to 2/3. So it's really interesting to see that the switching helps. Put differently, say I use guess 1 as my final guess to compare to the truth, as opposed to guess 2, and run this, I get 0.331. And the interesting thing about guess 1 is, the reason why it works is, all the code from if truth all the way to here, guess 2, is now irrelevant. So I can comment all of this out here in the middle, which I've just done, and just retain the assignment of the truth, which is a random number, the assignment of guess 1, which is a random number, and then I just check whether these two agree. And clearly the probability must be 1/3. All the story about showing the open door has no effect on this. And that little thing here, that I simulated it, and when I retain the original guess, that all the story about opening the door has no effect on the chances of my guess, prove that the chances to be 1/3 for the original door, and therefore switching goes up to 2/3. Isn't that cool? So this is the story of Monty Hall and the very famous quiz.